Awesome. Very, very, very warm welcome to everyone here today. Thanks all for coming to this session called You Need to Code from Rocket Academy. Clearly, the title shares a message, you need to code, and we believe that it's helpful for people to learn coding, which is why we're doing this workshop, which is why we operate our school, which trains people to be software engineers. And I'm super excited. I'm the founder and CEO at Rocket Academy. My name's Kai, and I'm super excited to be guiding everyone here and sharing why I think coding is important and relevant for us. Before we get started, who are we and why are we here? Rocket Academy is a live and online coding school. We train people to be software engineers and we help them get jobs at tech companies. We are based in Singapore, although we have friends like Fung in Hong Kong and staff in Hong Kong, and we have students from across the Asia region right now. And of course, we're looking to expand. So if anyone is, whether you're from Singapore or outside of Singapore and we can be helpful in any way, we would love to hear from you. And we'll have contact details at the end of this presentation. I will also share the slides with you. Coding is relevant. Why? Because there's a huge lack of software engineers in the world. And and we'll go into this more detail later on in the presentation. But the main reason is because of career opportunities, because there's a lack of software engineers and there's an opportunity for all of us to get into an exciting tech industry. And even for those of us who don't want to be software engineers, coding will be helpful for working with software engineers, because every company is becoming a tech company, and every tech company needs software engineers to build the software that they need. And so even if we're not software engineers, understanding what coding is will help us interact with them as the companies build the software products. Okay, so that's a bit of background about Rocket Academy and why we do what we do. This is a picture of Rocket Academy's bootcamp community. We had a gathering back in July. This was an event hosted at StashAway, which is a fintech company based in Singapore. It is an investment company, and they're one of Rocket's hiring partners, and they were kind enough to host us for our first ever community day with our bootcamp students. So this is the kind of community that you can expect: tight-knit, energetic community if you were to be part of Rocket Academy. Here's today's agenda. We are going to go through 3 questions together. And after that, we'll have the Q&A session where I hope to answer all the questions that you guys might have about coding or Rocket Academy or anything else. Okay, we're going to go through what is software. So many of us will know, but let's talk about it in a little more detail. 2, why code? Right? Why is it important for us to learn to code? We'll share through some examples. And 3, what is code? What exactly, beyond the apps that we see on our phones, what actually is it, and what is it all about? Okay, so let's go through these topics together. What is software? Now, many of us, as I mentioned earlier, I'm sure most of us have smartphones here, and many of us use applications on our phones every single day, from WhatsApp to Facebook to Messenger to Instagram to all the browser and all many different kinds of applications. And these applications are naturally built with code. And surprise, surprise, it is software engineers who are the ones who develop these applications and build them. And so, as software engineers, we have the opportunity to contribute to building these apps that are used on a daily basis by billions of people globally. So that's a little bit about applications. Software is also automation. It's not just applications. Right? We have some images here of some robots, and more and more factory work is being done by robots, and these robots are programmed with code written by humans just like us. And not only is automation about robots, it's also about scripts that happen in the back end when we do daily operations like deposit money or transfer money in our bank accounts, for example. Right? There are scripts in the back end that handle the withdrawing and depositing of money into different accounts that don't involve humans. Right? So the automation is a big aspect of what software can do for us. Silicon Valley, I bring this up because, as we can see here on the picture in the bottom right, Silicon Valley has inspired many across the world because of all these great companies that they've built: Facebook, Airbnb, YouTube, Intel, Twitter, Adobe, Uber, Coinbase, HP, right? All of these companies came from Silicon Valley. But the beautiful thing about Silicon Valley now is that every single country has its own Silicon Valley. We all need local software services for everywhere we live. And local companies that build software coming up in all of the countries that we're in, and they need people. So that's software is not just the companies coming out of Silicon Valley, but it's all the friends locally in our own countries that are trying to build companies like those in Silicon Valley to support our local needs. So software is also our local tech companies. And last but not least, I wanted to bring up emerging tech, right? Many of us have heard of these trends in recent years. Mobile started 10 years ago, and then it was AI. And we have some images here, right, of AR, VR, right? We have Pokemon Go here. And we even have, anybody recognize these pictures on the top right? Right, these are called bored apes,
NFT,
right? These
right?
is NFTs, right? Yeah, blockchain, Web3. And guess what? All of that is software. All of it is powered by code, and it is technology that all of us, if we were to become software engineers or learn to code, that all of us could take advantage of, build applications for, and take part in this emerging new economy. So that's a little bit of background about what software is. Now that you've heard about software, in case I haven't convinced you already, why code? And I want to just source some answers from the group. So for those of us who are listening, if you could just type in your answer to this, why should we code, in the chat box, I would love to hear some of your answers. Let's take a minute to do that. Okay, we have Jordan, who said it's a useful skill. We had Anastasia, who said to understand how computers work. We had Alexis to say solve some problem. Might be for a friend or for yourself. Maddie says we should code for the satisfaction of building something that helps us. I completely agree. Cynthia says to speak the universal language of the future. Hopefully we're not all talking in code. That'd be weird. Code for the future all around us. Feasibility as a designer. Thanks for that, Aparna. Creating UX designer, bridge the gap. Jasperina, love it. Learn how to communicate more smoothly with developers and engineers. Thanks everyone for sharing those ideas. I think all of them are great reasons to learn to code, and it's great to hear that there's a variety. Some people want to build stuff for friends. Some people want to connect the gap between designers and engineers. Other people want to learn the languages of the future and just be familiar with what's happening in the future. I think all of those reasons are great reasons. Let me dig into some reasons of my own as well. Okay, some of us mentioned that software is in the future. These are related to the images that I shared in the previous slides. This is, I mean, just this picture of the train alone is quite telling, right? Everybody is on their phones using apps, and we could be the ones building those apps that people are using in the future. There's so many of them. There's increasing number, and there are new innovations every year. And like what we said earlier, every country has its own Silicon Valley, and every country needs its own local services, and that's the potential. Beyond software being the future, we also know that there's great career progression for those who understand software and tech. And we have some images here of employees at Google. We have some images here of employees at Facebook. But it is not just about tech companies. It is not just about us getting jobs at tech companies. Even those of us who work at more traditional companies that also want to employ software to make their operations more efficient. Software and coding can also help with career progression at those companies, because you essentially get to, you understand the technology better, and you can better help your businesses provide value through software. So career progression is a huge reason for learning to code. And last but not least, briefly at least, coding is awesome, at least in my opinion. I mean, look at this cat with the lasers coming out of its eyes, right? you can do building Instagram at the time that it did, being able to apply these filters, being able to share cat pictures of other people. And even on a more serious note, AI, right? AI is incorporated into so many coding tools today. Just this example, this is Google Vision, which has a free tool. And if you just upload an image into Google Vision, it can tell you with a high percentage accuracy what exactly is in that image. And all of this is enabled through coding and is powering all of the everyday technologies we use in the future. Cool. Awesome. Now, before we proceed further, okay, I understand many people were not prepared to turn on your cameras, but I'm going to remind people again, for those who just joined, if you could turn on your cameras, that would be super helpful for me to engage the audience. If you're busy or you're not prepared to turn on your camera, that's okay too, but it would be helpful for me. So I appreciate that. Okay, oops. Before we go into the next segment is, so we just talked about what is software and why we should code. The next segment is, what is code? And so we understand that code builds apps, and apps are cool, and apps power the future, and apps, there are tech companies that build apps, but what actually is code? And I would love to hear from you guys again. If you could just type your answers in the chat, that'd be really helpful. Means of communication. Camila says means of communication. How so? Languages and machines. Yes, that's true. Sets of instructions. Yeah. Thanks, Jasperina. Sets of instructions that tells the computer what to do. Language that is used to communicate with machines. Love it. Language, ones and zeros. Yeah. How computers communicate. Love it. Yeah. All true. Everything you guys are saying is true. Computer functions. Yes. Love it. And if you join, well, I'm sure if you learn programming, you'll very quickly learn about functions. That's one of the things that we teach in our basics course. Set of instructions to the machine, computer. Great. Yeah, everything you guys are saying, computer's vocabulary, everything you guys are saying is true. It is a set of instructions to the machine. It is a language to communicate with machines. It is a means of communication, a language between humans and computers. Yes. Yes, all of that is true. And so if I had to summarize in just a single sentence what code is, it is like what many of you said in the chat. Code is the instructions we give to a computer. No more or no less. You can think of it like a bullet point list of instructions. And I'm going to show you guys some examples in the next few slides of what I mean by this. Okay. So if you take away nothing else, it's just instructions. Okay, so a friend of mine shared this example with me like last year. He was like, hey, actually coding is very much like cooking. And it struck me because I was like, oh, well, cooking seems so different. But actually, I realized that having recipes, right, and cooking with recipes is a bit like running an algorithm. And an algorithm is a set of instructions like what we just said coding is. So for example, I have a plate of chicken rice. Those of us who have been to Singapore or had Singapore food might know about chicken rice. It's very popular here. And I looked up a recipe online, and these were the 5 high-level steps. Clean the chicken, season the chicken, steam the chicken, cook the rice, and make the sauce. Sounds simple enough. And if I told someone a friend or human to make chicken rice, and I gave them these instructions, they could probably make a decent chicken rice. But there are a lot of assumptions that are being made in each of these steps, right? Like if I told someone, okay, you got to clean the chicken. If I told someone you got to clean the chicken, how are you going to clean the chicken? Season the chicken, how are you going to season the chicken? Steam the chicken, what temperature and what else would you put in there, right? And so if we gave a computer steps like this and expected a computer to complete it, assuming they had arms and were able to do it, the computer might struggle. because the computer may not have context or these assumptions about what a chicken is, how to clean a chicken, how to steam a chicken. And that is why when we write code, it is all about specifying instructions in as much detail as possible, or in the detail that we need in order for the computer to know what to do. So these 5 steps, if we were to convert it into computer language, might actually look something more like this. Right? And this is what, this wall of text here, right? All of the instructions is all from online. This is a real recipe, by the way. And this bunch of text is what most people might actually associate with coding, because they think it's intimidating. They think it's a lot of text and a lot of stuff to understand. But actually, it is just the high-level 5 steps from the previous slide. And someone has taken each of those steps and added detail to those instructions. Okay, so coding is just the detailed instructions so a computer knows what to do. And the beautiful thing is that there are enough software engineers in the world that much of the foundation, right? Some of this stuff like remove the chicken from the pot, right? Some of this foundational stuff like the pot and even removing the chicken, a lot of those stuffs have already been written by other engineers. So we can use tools that are already built. Okay, so coding is about instructions, and it's about breaking down the instructions for the computer to understand. I'm now going to walk everyone through a live example of a game called Flappy Bird. Now, some of us may have played this game before, right? You start it and you click a button to make the bird jump in the air. And the bird has to go through these obstacles in order to get through, right? But I'm going to show you guys how to code this, not with real code, with drag and drop programming, but the concepts are the same. The concepts of applying the logic to give a set of instructions to a computer are the same. Okay, so let's go through it. Okay, can you see my screen? Great, you can see Flappy Bird, right? Okay, so what you see on the right here is a set of blocks, so-called blocks. And this is the language that is used to create this interface here on the right is called Scratch. Scratch is a so-called block-based block. So each of these drag and drop things here is a block-based programming language developed by MIT to teach beginners how to code. And so beginners can use it. And the logical principles are the same between this and text-based programming. That's why this is so powerful. And this website that we're looking at here is called code.org. There's a link to it later on the slides, but this is where they have lots of free resources for learning to code. And you can try block-based programs like this. Okay, so you can build this from scratch. It takes a couple minutes to build this, but it underscores the logical principles of coding, which is why I wanted to share with you guys. Okay, so I'm going to do a demonstration. This is a completed game, but I'm going to start from scratch in a little bit. Okay, so I'm going to show you guys what it looks like. For those who haven't played Flappy Bird, you'll see what it looks like. So if you can see my screen here on the left is Flappy Bird. Maybe you can hear the sound as well. Hopefully it's not too loud. The idea is that Flappy Bird needs to go through these obstacles in order to get as high of a score as possible. And if you hit any of the obstacles, of course, you game over and you need to reset. All right, so my score is 5. Again, I can play again and try and get a higher score. It's quite addicting, so just be careful there. Right? Okay. So hopefully all of you saw that demonstration and could understand generally how Flappy Bird works. All right. So that is what it looks like when the game is fully coded. But let's start from scratch. Okay, so I'm going to click this start over button. Start over, and now I have nothing. So if I reset this game and I click start the game, nothing's going to happen. The bird will just drop to the ground because I haven't told the bird to do anything. And that's the beauty of coding, right? The computer does exactly, and I mean really, literally exactly what we tell it to do. And, but of course, in the language of the computer, right? So in this case, we haven't told it to do anything. So well, it doesn't do anything. There's some gravity built in, so that happens automatically. But other than that, there's nothing that happens, okay? So I can just drag one block in. So one of these blocks is set the speed. So speed of the universe of Flappy Bird, right? So I am here and I'm going to just drag one block, set speed, and I'm going to reset and play. And let's see what happens. So I only did one thing, move this one block here. So when the game runs, set the speed. Okay. So we can see the ground is moving, the game is moving. When I start, the same thing happens. The bird drops to the ground. I pass through the obstacles, but the thing is moving. Nothing else is happening. Okay. Again, very logical. I haven't told the computer to do anything other than move the ground. Okay, so hopefully that makes sense to everyone. The computer does exactly what we tell it to do, no more, no less. Okay, so let's make this game happen. Right. So when I click the start button, I want to set the speed to normal. Okay, maybe I want it to be very fast, so I can change the setting. This is something built into Scratch. I can set the scene. I can set the player. It doesn't have to be a yellow bird, right? So I can make it a red bird. I can change the scene, right? So in programming, we can provide these so-called parameters to all of our functions. And so this is a concept that is common in programming. I can change the obstacles to be lasers. I think lasers are cool. Set the ground to be lava. I can set a normal gap between obstacles, set the gravity, set the score. Okay. When I click, I want to flap the bird. Okay, so I want to make the bird go up. I want to play a wing sound. And so in the completed version of this game, when you hit the ground, you usually game over, right? Same thing when you hit an obstacle. When you pass an obstacle, you score a point. Just to demonstrate this concept of the computer doing what we tell it to do again, I'm just going to make it always score a point. Okay, so every time when I hit the ground, hit an obstacle, pass an obstacle, just always score a point. Okay, so let's see what that looks like. Okay, so I'm about to start the game. It's lava and lasers. Right, so I'm trying to go through. And you notice, even if I go through the obstacles, I'm scoring points here. I'm just scoring. I'm just running away with this game. Right, and even if I go up and beyond, I'm still scoring points. Even if I drop to the ground, I'm still scoring points. I'm just scoring points all the time. Right, this is a great game. But probably not too challenging, right? Most of us want a more challenging game. So again, it's an example of the computer doing exactly what we want it to do. We're telling it, score a point always. Okay, but that's not what we want. What we actually want is this thing to end the game when we hit the ground and hit an obstacle. So I can do the same thing. I'll drag the end game block to these two conditionals when I hit the ground and hit an obstacle. And now the game should be complete. So let's try it. You guys ready? Okay, so I'm going to jump through the hoops, jump through the obstacles. And at some point I'm going to hit one, but not yet. Oh, okay. Hit the obstacle and game over. And the same thing if we hit the ground. Okay. What did we learn from that? We learned that the computer is code is a set of instructions that we tell the computer, no more, no less. If we tell it to give us points for every obstacle that we hit, it will give us points for every obstacle hit. Right. So that is the power of code. It just does what we tell it to do. And if you guys have any questions about that, please ask me in a little bit. Figure out how to change this back. Screen back. Get back to the other screen. How do I do that? Oh, maybe I need to go back. Oh, there we go. Okay, back to this slides. Okay, so that is Flappy Bird, and hopefully that was a good demonstration of what code is and how it works. When we put in a wrong instruction, it will do the wrong instruction, for example. Okay, now I just have a few more examples before we get to the Q&A. I wanted to give us some examples of apps that we use every day and how code is used to power them. So if you guys remember the chicken rice example, right? There were a set of simple instructions that we do to make chicken rice. Similar thing in our apps. Where, for example, with WhatsApp, right? When we want to send a message to our friends, it is just a set of simple steps. And some software engineers have taken those simple steps and broken them down into clear instructions for our for the computers to run. So WhatsApp messages, what is it doing? Sending a message to the database, push that message from the database to other group members, and display the message in their apps, right? The logic is simple, and each of these steps can be broken down further by software engineers to instructions. Same thing with bank transfers. DBS is a popular bank in Singapore. When we make a bank transfer through the DBS app, all it is doing is reducing the source account balance, increasing the target account balance, and showing the confirmation page. Of course, there are multiple sub-steps. Maybe they have to do some security checks. They have to verify authentication. And all of those are detailed instructions that software engineers implement beneath each of these steps. And for a even more complex example, we might have ride hailing. Grab is a popular ride sharing app in Singapore. And when we match with a ride, really what's happening is, one, the app will match the rider with the driver. So there's some calculation there, of course. Two, show the driver location and the distance to the rider in the app, so they know how far away the driver is. And three, continue sending the live location until the ride is over, so that the company can verify that the ride happened and everyone was safe and the ride was completed. Right, so coding is this series of instructions that can be broken down into simpler and simpler instructions for the computer. All right, hopefully that was a good helpful introduction to what coding is. I just wanted to highlight one more thing about coding before we get into the Q&A, because many of us here will be starting and new to coding. And when we go look up free coding courses online, we might encounter some courses that teach us languages like HTML and CSS, and some courses that teach us languages like JavaScript and Python. And what is the difference, really? The difference is that some of these languages are user interface languages that control the looks of how an app or a web page looks like. And the other languages are logical programming languages that define the functionality. And both can be used together, but they have different purposes. Right, so HTML and CSS define, hey, where should this button go? Where should this image go? And so those are the languages for that. And logical programming typically requires introductory languages like JavaScript and Python that define the functionality. What happens when I click an image or click a button like this like button, right? It has to record the like, send the like to the database, and push the like to the other users, just like the instructions we shared on previous slides. So I just wanted to point this out in case anyone is starting to learn programming and you're wondering what's the difference between these languages. Okay, we've curated some resources for you. So if anyone is starting to learn coding from scratch, these are the resources that we would recommend as Rocket Academy. These are all free, they are all online, and they're high quality. And so we've curated, there are tons of resources online, but these are the ones that we've curated that we feel are the most relevant. I will also share these slides with you afterwards, so you don't have to take notes right now. And if you do those free courses and you like it, and you realize, hey, this might be a career for me, or I might want to learn more about coding, Rocket Academy offers courses for beginners to get into this field. The course that I would recommend for starters is called Coding Basics. This is our introductory course for coding, 6 weeks part-time, led by instructors live and online. Hundreds of students, or thousands of students actually have gone through it. And we have a special referral code for everyone here. It's called YNTC. And if you register for our Coding Basics course with this code, you will get $20 off. So please use this code when you're registering. And for those who do Coding Basics and are interested and passionate to go further, and you think that a career in software engineering is for you, which we would love, Rocket Academy offers a coding bootcamp course, which is either 8 months part-time or 4 months full-time. It prepares people for careers in software engineering. And so far, 100% of our bootcamp graduates that applied for jobs have received offers within 6 months of graduating. So at great companies. And so these are the courses that we offer if you're interested and more serious about learning coding. Great. So that's all for the prepared session. What we're going to do now is jump into a Q&A where I hope to answer everyone's questions. I know you guys were engaging in the chat earlier, so if you have any questions about coding or Rocket Academy, happy to answer them now. You can just scan this QR code or jump into slido.com and enter this number. I'll be monitoring it, and it's going to show up on the screen. And before we end later today, at the end of the session, what I'm going to do is share the contact information and share a feedback form that we can all do at the end. Okay, but before we do that, let's do the Q&A. Hey, Ian, thanks for the question in the chat. If you could just put it into Slido, that would be really Really, really helpful. But I can answer it now in anticipation since you're the fastest fingers. Okay, Ayin had a question. So is HTML and CSS for more front-end software engineers or back-end users more Java and Python? Yes and no. I would say actually both front-end and back-end software engineers need to use the UI languages and the logical languages. For example, JavaScript is very common in the front end. Many of us will have heard that because the front end also requires logic. What happens when you click a button? That is still part of the front-end software engineers or front-end engineers' responsibility. Of course, back-end engineers don't use as much UI languages because they're focused on most of the back-end logic. Hopefully that answers your question, Ayin. Okay. What are the timings for the basics course? Yes, the basics course meets from 7:30 to 9:30 p.m. on Mondays and Thursday evenings, Singapore time. And Singapore time is GMT +8, so it's in that particular time zone. So just pay attention to time zone. If you are from a time zone that is different and those times don't work for you, please let us know because we are looking at how we can support people from more time zones and we would love to see how we can support you as well. Awesome. When is the next full-time bootcamp after November? Actually, the upcoming full-time bootcamp starts in October, if I'm not wrong. And the next full-time bootcamp after November starts in January. So we have a new bootcamp every 3 months. And yeah, we have a new bootcamp every 3 months. And yeah, if you're keen to join or you're keen to explore, we would love to hear from you. One note, though, is that in order to join our bootcamp, students need to have some prior experience. And if you have no prior experience, we recommend that students join our introductory basics course before bootcamp, because our introductory basics course teaches people everything they need to know in order to join our bootcamp. Hopefully that answers your question, Anonymous. January is the next one, next full time after November. How long will it take to learn coding? Wow. How long did it take you? Man, I'm still learning and it's been 10 years. So there's really no end. I would say there's no end. There's not a single point where you can say, okay, I learned coding, I don't have to learn anymore. I think all of us can attest to this. It is a continuous journey of learning. I would say, I studied computer science at university. I studied at Stanford, studied computer science. I did an undergrad and a master's there. And so I studied there for about 5 years. I interned a few times at Facebook and Alibaba before working in Silicon Valley as a software engineer. And so it's hard, for me, I spent that amount of time and I'm still learning. But for many of our bootcamp grads, for our bootcamp grads, Rocket Academy, within 6 months, they have all, at least the ones that have graduated, have all secured software engineering jobs within 6 months of graduating. So I would say this about learning coding. The practical skills don't take that long to pick up. Most of what people learn in university is the theory. The theory is more important when you're doing more advanced coding, advanced software engineering, but you can pick that up on the job. So what I would recommend for everyone here, if you're interested in learning coding and getting into tech, you don't need to go for a university degree. Join a shorter course, learn coding, get a job as a software engineer, learn a ton on the job, and learn the computer science theory that you need to do more advanced work in databases or networking. Learn that on the job, because that is going to take you further faster than if you spent 4 years upfront trying to learn coding and computer science at the same time before even starting your work as a software engineer. So that's what I would recommend. There are so many coding languages. Where do I start? Man, I would love. Yeah, these are great questions. Keep them coming, guys. Thanks so much for the questions. The languages that we shared on the previous slide, HTML, CSS, JavaScript, and Python, those are far and away the first languages I would recommend anyone learn when you're doing coding. Why? HTML and CSS are the foundations of the internet, really. All the web pages we visit, even the one we're on right now, this Google Slides thing, all of it, ultimately, it's HTML and CSS. So if you're looking at building websites or understanding how websites work, HTML and CSS is where I would start because that's the foundation. JavaScript and Python are two of the most common programming languages in the world. And they also happen to be two of the most simple programming languages in the world. And so if you wanted to get started with coding, especially the logical programming languages, JavaScript and Python are absolutely the ones I would start with. What's the difference between the two? JavaScript is more commonly used for building applications, like the applications like Google Slides or the applications we use on our phones or most of the websites we use. Python is more commonly used for data analytics, machine learning. So if you're more into data, Python may be a better starting language for you to do. Hopefully that helps. What sorts of skills are essential for coders/programmers in terms of thinking, critical thinking, systems thinking, etc.? I love this question. Thank you for asking. I think you're absolutely on the right track. Critical thinking system. I would summarize it as logical thinking, 1, and 2, communication skills. These are the 2 most important skills for software engineers or coders or programmers, in my opinion. Why? Logical thinking, I think you guys understand, right? It's the set of instructions, right? You need to, if you tell the computer to give you a point every time you hit an obstacle, like in Flappy Bird, it's going to give you a point for every time you hit an obstacle. And so we need logical thinking in order to be able to understand when we told the computer the wrong thing and to be able to fix that. So that's logical thinking. The second thing, communication skills. This is very, very underrated, highly underrated. If you ask any tech company or any software engineer, they will probably say that, hey, this is super important. Communication skills. Why? Because software engineering is almost never an individual activity. It is almost always a group activity. You know, one person couldn't have built WhatsApp. One person couldn't have built Facebook. It is all a team effort. And in order for the team to work together effectively, they have to understand what each other is trying to do. If engineer A goes and builds a feature, engineer B's feature needs to interact with engineer A's feature, they need to understand what each of their code does. And that's where communication skills become super important, because without clear communication in terms of the variable names you choose for your code, or the comments that you write in between your code to explain it, or the documentation that you write to explain to other people what this code does. If that is not clear, the teammates will not understand. They're going to make a mistake when trying to work with your code. And there are going to be bugs. We've all encountered bugs in software before, right? Facebook goes down, or like you click a button and it doesn't work on a website, right? All of those are typically results of miscommunication. And so that's why logical skills are important, but also communication, especially because that's what enables teams to work effectively as software engineers. Hope that helps. Do we get to learn both the version, HTML and Java, in the basics course? Both the versions of languages, I assume you're talking about. Yeah, great question. Yes, the answer is yes, but we focus on JavaScript. So we don't teach Java, and Java and JavaScript are 2 completely different languages, and they're quite different from each other. So just take note of that. Java is a logical programming language though. And we focus on JavaScript in the basics course because JavaScript is one of the introductory languages that we mentioned earlier, especially for building apps. And at Rocket Academy right now, in order to prepare ourselves to be software engineers, the focus is on building apps and understanding algorithms. We are working on data-specific courses in the future that will involve Python, but we haven't launched those yet. In the meantime, the foundation we recommend is JavaScript. So we learn both HTML and JavaScript, but the focus is on JavaScript because that tends to be more complicated than HTML. And that's where I think the foundations, we need to learn the foundations in logical programming first as software engineers. HTML and CSS is relatively straightforward to pick up. Should we self-study before going for basics? And if so, where should we start? That's a great question. You for sure do not have to, because basics is geared toward beginners. So even if you have never seen a line of code, never even heard about what code is your whole life until this presentation, hopefully, you would still be able to pick up from the start of basics and get your footing and complete should be able to complete the course, assuming you're diligent and do the homework. That said, if you want to get ahead and you know that you're serious about becoming a software engineer, there's no harm in self-studying before going for basics, because there's room, if you are advanced, there's room for you to do more advanced stuff in basics and even our bootcamp course. So you don't have to limit yourself. If you know that you're committed, you can start going now. Where should we start? I would recommend, on one of the previous slides, I curated some free resources. That's where I would start. I would start with code.org, Codecademy, Khan Academy, and even Harvard has a course called CS50 that is super popular. I would recommend it online. It's great quality and it's free. I would recommend those courses. I will share the slides with everyone afterward. Working with designers, what do you wish that they can do or learn to make your job easier? That's a great question. I've worked with designers before. I think, and you guys hit the nail on the head earlier when we were asking why code, right? Some of you said that, hey, I'm a designer. I want to try and work better with my engineers. I think it would be helpful if designers understood how the designs get built in the code. How the UI programming works and how the logical programming integrates with that to perform functionality when you click a button. Because if designers understand how the engineers have to put together the UI that they're designing, then they can better anticipate the problems that engineers are going to face when they build. For example, I build a UI and I know it's got a bunch of subcomponents. I can maybe, for example, if I reuse a component in my design, so that the engineers, they only have to write that component, that UI component once, and they can reuse it in different places in the app, for example. But if the UI component is different in different places in the app, then the engineers have to code it differently every time. Things like that. I think if designers understand how the engineers need to do their work, then it might actually make things work faster. Hopefully that answers your question. We have had designers go through our basics and bootcamp courses. So if you're keen, happy to put you in touch. Just reach out to me afterward. What is a typical day for a software engineer? Great question. Love it. It depends highly from company to company. Right? Some companies, especially startup companies where they're struggling for survival and they have to work super hard to just make sure that they build the right thing for their customers just to survive. It can be pretty intense for software engineers, right? Because company survival depends on it. You just have to get the software out so that the users can use it. Otherwise, the company may not live that much longer. So that's the situation at some startups. At larger companies, and depending on what team you're on, it can also be intense. Right? I used to intern at Facebook, and when I worked there, the engineers there were some of the most hardworking engineers that I've ever met. They were working from day to night. They really just, because they cared so much, they were just really passionate about what they were building. And so the typical day for a software engineer, some companies have more, some companies have fewer meetings, but for the most part, good tech companies know that software engineers need focus time. So most of the time, the meetings are consolidated to 1 or 2 days and just a few hours in a row on those days. And software engineers usually are able to focus. They're able to start work in the morning, usual hours, office hours. Usually there's some kind of scrum session where the team of software engineers will get together. They will share with each other, what am I working on today? What did I do yesterday? Is there anything I'm stuck on? And once that meeting is over, it might take 15 minutes, and then everybody will go into focus mode on their projects. And they usually communicate over a chat platform like Slack. It's a bit like WhatsApp, but for tech teams. And they usually communicate there. And yeah, that's it. There may be some meetings with product managers or designers along the way, but for the most part, software engineers are focused on their code. And when they're focused on their code, the majority of the time is spent learning new things. So that's the fun thing about being a software engineer, is that you're paid to learn. Because once you've learned something once, it's very fast to implement it again with a different app or a different product. So most of the time is actually spent learning what is not working about my app and how can I implement this feature using this new technology. So hopefully that helps. What language would you recommend developing for Web3? This is a great question. I'm also learning this myself. So it's great to hear that some people here are already interested in Web3, even if you may not have been a software engineer before. There are generally two really popular languages with Web3 today. One is called Solidity. I'll repeat that because it's a bit tricky. Solidity. And that is the language for the Ethereum blockchain, which is the most popular blockchain platform in the world today, Ethereum. That's also why Ethereum is so popular. But Ethereum has had some limitations, especially about scalability. And so in recent years, there have been new blockchains, particularly one called Solana, which is also much more popular, that was developed because of scalability reasons, in that some of its transactions can be more efficient at scale. And the language that is used for Solana blockchain is called Rust. And Rust is a more complex language, more similar to C++. If I had to compare Solidity and Rust to more traditional programming languages, I would say Solidity is more like JavaScript and Rust is more like C++. And so many of us will not know what that means, but JavaScript is one of the most simple basic languages that we learn. C++ is a more advanced language that is closer to the computer, requires a lot more effort on the part of developers to get things working, but it can be more efficient. So to answer the question, I would recommend Solidity because it is simple like JavaScript, and Ethereum is the most popular blockchain. But if you're looking to go deeper, I think Rust is a quite popular language nowadays to build more efficient applications on the Solana blockchain. Awesome. What type of company, old versus new, startup versus non-startup, will be best for an entry-level software engineer coder to start in? Great question. Really, really great question. I love that you asked this. Many of our students also have this question while they're going through the course or even after they go through the course. I think a lot of it is personal preference, right? I can't say that, oh, some company, I can't say that an entire class of companies, let's say old startup companies, are bad. I can't say any class of companies like new non-startup companies are bad. I can't say that because the truth is there are good companies in all of these categories that I would recommend joining. But it depends on what you're looking for. So different categories of companies tend to have different traits. For example, I mentioned earlier, startup companies tend to be more intense because you either succeed or die. That's what startup life is like, right? You either build a product that people love or you run out of money tomorrow. And so that's why for people who are looking for an experience where you are thrown into the fire and you are forced to learn or die, not really die, but figuratively die as a company, and you thrive in that kind of environment, then I would recommend joining startups because you'll be forced to do everything. There's nobody else on the team to do some of the stuff that needs to get done. And even as an entry-level software engineer, you just have to learn how to do Web3 or how to do DevOps or how to do mobile or how to do machine learning because there's nobody else and you just have to do it. So if you like that kind of forced, fast-paced learning experience, startups are great. On the other hand, larger companies that are more established tend to have more resources for training and mentorship. So if you are an entry-level software engineer who likes structure, who likes stability, who likes a more regular work cadence, who likes the support of especially more experienced people who can help guide you, non-startups tend to have more of those types of people and more of those kinds of environments. So I can't say which one is right or wrong. It really depends on your personal preference, what you're looking for, especially at this stage in your career. And of course, between old and new companies, I mean, there are old companies that are amazing and there are also new companies that are amazing. So that one, I think, doesn't really make a difference. I think what makes a bigger difference is the quality of the team that they're joining, regardless of startup or non-startup. And you will have to be the judge for that when you go for the interviews. Do I respect this team? Can you learn to be a web developer, game developer, or other IT roles instead of being a software engineer? Great question. I love this question. Thanks for asking. Software engineer is a very broad term, and many different people have different definitions of software engineers. Some people think of software engineers as front-end engineers. They are focused on HTML and CSS, and they are masters at it. And some people really are. Some people really are. And some people think of software engineers as back-end software engineers, and they are the back-end experts. They are super good at logic. They can build any kind of logic or API server or database that anybody wants. The way I think of software engineer is in the general sense. A software engineer is someone that can go into any code base, any set of code, anywhere in any company on any product, understand what it does, and make the fixes that they want to see. Regardless of language, regardless of framework, regardless of how complex it is just, at the end of the day, it is just code. And all software engineers should be able to read and understand code and update it to make it do what they want. So in my opinion, given that definition, I would say web developer, game developer, and other IT roles, these are all subsets of being a software engineer. Because if you're a software engineer, you can do any kind of software at any company, at any industry, in any country. That's what a software engineer should be able to do. And it opens so many doors for you. And that is why Rocket Academy's courses, basics and bootcamp, are geared toward training people to be software engineers, not web developers, not game developers, not machine learning, not IT developers, software engineers. Because if you're a software engineer, you can do all of the above. Hope that helps. Are software engineers starting to work from home or sometimes office? What job environment do you prefer? I'm lucky in that I have space at home to work. So I prefer to work from home, but and it gives me focus and I feel comfortable at home. It's less commute time, so that saves me time in the day. But I understand that many people don't have a comfortable place to work at home, or there are kids, or there are other things going on at home that makes it inconvenient. And so I understand that some other people prefer the office as well. Personally, I like working at home, but I also love seeing my teammates when I can. So we try and get together. But most of the time, I prefer to work from home. How can one future-proof their career as a software engineer? Great question. I love it. Thank you for asking. What sort of new technologies to look out for? Yes. And so something we mentioned earlier on in the presentation is that the learning never stops, right? Someone asked, oh, well, how many years did it take you to learn to code? Or how long did it take you to learn to code? The truth is the learning never stops. The moment you stop learning, the moment you start stagnating, the moment you start being less useful to the industry. And so to future-proof your career as a software engineer, I would recommend continue working on projects. So some people, they work at one company for a really long time. And at that company, they may get really, really deep on a particular project that uses the same technology, and you're improving on that technology. But if you're not keeping up with the trends of the industry, then when you leave that job and you go out and you try and apply for other jobs, or or work on other projects, you might feel a bit lost. Because if you've been so stuck on that one particular technology for a long time, it might be more difficult for you to go and pick up new technologies. So to future-proof your career as a software engineer, I would say, hey, always keep learning. Look out, what are the new trends that are happening? Join communities, join Rocket Academy's community. We have a Discord, free Discord, where you can keep in touch. Join local communities, wherever you are. I'm sure there are software engineers that want to share and talk about their work, hear what they're working on, and work on these projects. Right? There are so many free resources online for learning things like Web3, for DevOps infrastructure, for machine learning, for mobile, even security. Right? There's so many free resources online. Just follow your passion and keep learning. That's what I would recommend. That's the beauty of this industry. We're paid to learn, and we get to keep learning for our whole careers.
Perfect. I think that's it.
All righty. So thank you everyone for your questions. If you have further questions, I'm going to stick around afterward if anyone else wants to chat or learn more about Rocket Academy. Before we go though, I would love to take a picture with everyone to just celebrate this time we've had together. But before I stop sharing my screen, I also wanted to share that we have a feedback form. So if you have time now, please, if you could scan this code or copy this link, Fung will copy it into the chat. Really, really appreciate if you could share feedback on this event, how we can make it better. Our contact information for Rocket Academy is here on the right. So if you have any further questions, just email hello@rocketacademy.co or message us on any of these channels and we'll be happy to respond. But email is the best. And would love to hear from you guys. Okay, everyone scan the code. I can't see you, so you have to tell me somehow.
I put the link in the chat as well.
Okay. All right. But before I go off, I hope we can take a picture together. So if you're able to, would love if you could on your camera so we can take a picture together. Thanks, guys. Really appreciate it. Thanks, Yoma. Thanks, Alexis. All right. Thanks, Markini. Okay, wait. I'm getting ready. Okay. Anyone else? All right. Well, I'm gonna send this picture to you guys afterward. All right, ready? What else? Okay, ready? 1, 2, 3. Thanks so much, guys. Really appreciate you coming. Please leave feedback using that link that Feng shared in the chat. We would love to hear from you. And if you're interested in any of Rocket Academy's courses, really, really excited to hear from you and would love to chat further. That's the end of today's session. I'm going to stick around in case anyone wants to chat further. But if not, have a great evening and thanks so much for your time.